our Unit 5 study guide. Number 1. On the graph below, sketch a parabola that will have the following characteristics. So a parabola is going to have the value of its discriminant is 0, and the value of a in our standard form is negative. So with discriminants, remember that we have 3 possible outcomes. I don't know if I spelled that right. We have a positive discriminant where we have 2 x-intercepts. We have a 0 outcome for our discriminant where we have 1 x-intercept. And we have a negative outcome where we have 0 x-intercepts. That's where we don't have any solutions. And remember, our discriminant is that part of the quadratic formula, b squared minus 4 times a times c. So if the outcome of this is positive, then we have 2 x-intercepts. If it's 0, we have no x-intercepts. And if it's a negative, it's no solution or no x-intercepts. So for our problem here, our discriminant is 0, meaning that we're going to have 1 x-intercept. And then looking at the second bullet, the value of a in a squared plus b squared plus c equals y is negative. So if a is negative, that just means our graph is going to open downward. Right? So remember that a is responsible for whether your graph opens upward if it's positive, or downward if it's negative. So you just have to make a generic sketch. There's no quadratic given that we can graph. So we know we're going to have, and again, this could go anywhere on this x-axis here because it's an x-intercept. So I'm just going to put it here. So there's our 1 x-intercept that our parabola is going to have, and we know that it's going to open downward because a is negative. So you should just sketch something like this. Okay, and again, you could have chose to do it on this side. That's not wrong. Or you could do it out even further out. Doesn't matter. As long as you have 1 x-intercept and your parabola is opening downward. Okay. And what it would look like if you have 2 x-intercepts, then you would have a graph that looks like this. You have your 1 x-intercept here and another x-intercept here. And if you have no x-intercepts, your graph would look something like this, where it's opening away from the x-axis. But for this problem, for now, we want to see this here. Going on to this problem here. So it says, given the sketch of a parabola below, what can you conclude about the discriminant, the a value, and the c value of its equation? And we need to be specific about this. So looking at number 1 here, it says this discriminant must be, and our choices are positive, negative, or 0. So if we're looking at the x-intercept, because remember the discriminant tells us the x-intercepts. We have 1 x-intercept here, 1 x-intercept here. So we have 2 x-intercepts. And we know that a positive discriminant gives us 2 x-intercepts. And our discriminant is a positive, whatever number is under there, that gives us 2 x-intercepts. So because, and then we just make that statement. So positive discriminant gives us 2 x-intercepts. Now looking at number 2, the a value must be positive, negative, or 0. So if we're looking at the a value here, remember the a value is responsible for opening our graph up and down. Since our graph opens down, it must be negative. Right? That goes back to the quadratics that we had. So the a value must be negative because the graph opens down or downward, however you want to write it. That's not downward. And the last one there, the C value must be, and remember the C value here is responsible for the y-intercept. So the C value, if we're looking at it, it's above the x-axis, and all these y values are positive, so our C value must be positive because the y-intercept is positive.